4.3 objectives. I'm going to read it really fast. Ready? Use the product rule, use the quotient rule, use the power rule, expand logarithmic equations, condense logarithmic equations, use the change of base property. One breath. Okay, ready? Product rule. Remember I told you yesterday you already know these. Okay? But just to make sure, so I have some proof to back that up, remind me exponent rule wise what happens here. When you're multiplying like bases, what do you do with the exponents? You add them. Okay? So b to the m plus n. Okay? So the product rule says if you have log base b of mn, and I ask you to expand that, that becomes log base b of m plus log base b of n. When things are being multiplied inside the logarithm, we use the product rule and we add each individual term. Does that make sense? Okay, so that's the product rule. Now let's talk about the quotient rule. Okay, remind me about this. B to the m divided by b to the n. What do we do? When we're dividing like bases, what do we do with the exponents? That's correct. We subtract. Okay, so we're going to use the quotient rule. And the quotient rule says if I have log base b of m over n, that is log base b of m minus log base b of n. Okay? Then power rule. Power rule is what's next. So once again, you remember the exponent rules. B to the m raised to the n. When I have a power to a power, what do I do? Multiply, right? So that looks like b to the m times n. So the power rule says log base b of m to the p power becomes p log base b of m. I take that exponent and bring it down in front as a multiplier. The power becomes a multiplier. Okay? So we've got to know product rule, quotient rule, and power rule so that we can expand and condense logarithms. Does that make sense? Okay. Yes, absolutely. Is that enough? Okay. You got it? Okay. So here we go. Log base b of x squared, the square root of y. And I would like you to please expand this. Well, for expanding it, that means we're going to have the log base b for each one of the terms. So in this case, I'm going to write log base b twice because there's two terms here, right? Okay. So what happens with this first term? It would be log base b of x squared, but we know what's going to happen to the squared. Yeah, it's a multiplier, right? So 2 log base b of x. What are these things doing to each other? They're multiplying, so we're going to use the power rule, and I add, right? Log base b of, the square root of y? We don't want square roots in logarithms. Can't we rewrite y to some power to be the same as square root? What is it? Y to the 1/2, right? So what do I do with that 1/2? Where does it go? Down in front. Does that make sense? So like that's the problem. That's the whole problem. That's done. Okay, here's another example. Log base 4 of the cube root of y over 36 x to the 4th. So what do you want to write first? First of all, how many times are we going to write log? Once, twice, 3 times. Right? Once for the y, once for the 36, and once for the x, right? Okay, so log base 4 of cube root of y. Oh, that's really y to the 1/3, right? Okay, what do I do with the 1/3? Put it in front as the multiplier. So 1/3 base 4 of y. Then what? Minus, because I'm dividing, right? Minus log base 4 of 36. But what do I put between these two things? Isn't this still being divided by the y? See, that's what gets people sometimes, right? It's still being divided, but it's also being multiplied by 36. So I'm going to show you 2 things here. Okay? I could do this, because then this would be a plus, wouldn't it? Because these 2 things are being multiplied. It would be 4 log base 4 of x, right? But I'll tell you the computer's not going to like that, because it's not all the way simplified. Because what it wants you to do is distribute that negative to each one of those terms. Does that make sense? So what it's going to want is 1/3 log base 4 of y minus log base 4 of 36 minus 4 log base 4 of x. Does that make sense? Do you feel comfortable expanding? Can we go backwards? Can you condense? Well, let's try it, right? Log base 4 of 2 plus log base 4 of 32. What's that going to equal? Sorry, I started writing uphill. I don't know what happened. What am I going to do with these 2 numbers? Multiply them, right? So what is 2 times 32? 64? I'll tell you right now, if you put that in the computer, it won't count it right. Because if we think about it, this is the same as this. And what do we know about bases? When they're the same, what's left is the answer, right? So just 3. Does that make sense? Log of 4x minus 3 minus log of x. What's that going to equal? How many times do we write log when we condense? Only once, right? So I'm going to go ahead and write it. So weird, crazy kids right now are going to say, wait a second, what's the base? And you're going to be like, ugh, ridiculous. We all know the base is 10. Because it's not written, so that's the common log, right? It's a base 10. Yeah, already 10. We probably wouldn't say that because we're much more polite than that. We would say, oh, remember, it's base 10 if it's not written. Okay? All right, what's this asking us to do? Divide. So 4x minus 3 over x. Done. I can't simplify it, can I? This term doesn't have an x, so I can't like factor out an x from the numerator and cancel that out, can I? No, I'm done. What about this one? 1/2 log of x plus 4 log of x minus 1. How many times do I write log? Once. So there's my log. What's this asking us to do? Multiply. What is this going to do? So it's going to go up here as an exponent. So we could put square root, or we could just put x to the 1/2, right? And then what's this going to do? Exponent again, right? So x minus 1 to the 4th. Done. Because do you want to multiply that out? Neither do I. So just like you said, we could write it like this. And I'll be honest, I don't remember what the computer wants here. I don't know if it wants this one or this one. Both of them are right, so if you put one in and it doesn't like it, put the other one in and try it out. Okay? All right, one more. 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y. There's my 1 log, since we're condensing. Oh, log base b, sorry. What do I do with this? So x to the 4th. What do I do with this? Oh wait, what does this mean? Divide, okay. And what do I do with this? So what is 6 squared? 36, right? It definitely will not want 6 squared. We want to simplify when we can, right? And then what does it mean when I have 2 minuses? Do I put another divide sign right here? Oh, okay, both of these are on the denominator. So what do I do with this? Y to the 1/2. Excellent. What's the other thing we could write here instead? Log base b of x to the 4th over 36 square root of y, right? Okay. Expanding, condensing, you feel comfortable with that? Yes, absolutely. Okay, you're welcome. Feel comfortable with 1 through 5? So all we have left is change of base property. Okay, change of base property is almost obsolete. We still have to cover it because it's still part of what our objectives are, but our calculators do it for us now. Okay, our calculators, we can put in any base now, but you still have to know the, I don't know what that said. You still have to know the change of base property, so let's make sure you know it. Okay, if it tells you log base b of m, change of base property is log of m divided by log of b. The base goes on the bottom of the fraction. Okay, so we didn't used to be able to do anything in our calculators except log base 10, log base 2, and log base e. That's the only bases that we could used to use, so we had to have the change of base formula. Because change of base formula moves it into log base 10, right? Like I said, our calculators will do this for us now, but we still need to know the change of base formula because it's still asked for. Okay, so this would be log of 7 divided by log of 4. And if all it asks for is the change of base like property, just put that. That's all it wants. Now, if it tells you to round to 3 decimal places, it literally wants you to put that in the calculator and hit enter. Okay? In this case, it would be approximately equal to 1.40368. What if it says natural log of 7? What's the change of base of property there? Log of 7 over log of e. Right? Remember the base is 10, the base is e right there, right? Run fast, jump high, turn left. Okay. Any questions about this? That's it. That's all we got. Yeah. That's all we got. Okay.